Good day and welcome to my YouTube channel. I am Arthur Francis Deban. If you're stopping by for the first time, I would advise you press the subscription button, like the video, and also activate the notification bell so that anytime I upload, probably you're going to get it and you'll be informed in the process. So it's a pleasure to be with you again. Today, we're going to be dealing with Graham's Law of Diffusion. In 1833, an English chemist, Graham, carried out a research to find out that truly gases that are less dense have a rate, they diffuse faster than those that are denser. So in his conclusions, he came forward with a law that at constant temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of its vapor density. Now, what's diffusion? The process by which gases move from a more concentrated or dense medium to a less dense medium, and as such, it's been transferred throughout the medium. For example, if I should use my perfume right now, at this point where I am of the room, here is where the concentration of the perfume is higher. But within a short time, somebody at the other end of the room will be able to perceive it, which is the movement of that perfume from a denser region or a more concentrated region to a less dense region, but it's been sent throughout the room. So we're going to check out the calculation or the formula principle of diffusion, which Graham's put forward. So he said the rate at which gas diffuses is inversely proportional to the square root of its density. Now, if I have to say, remove this to bring the equality sign, that would be k times 1 is that over the density. So this is what Graham is trying to explain to us, that when the rate or when the gas is denser, the rate of diffusion will be lesser, inversely. So when the rate is higher, means the density of the gas is lower. That's all. But in the scenario where we're having two gases, so if this is it, okay, where we're having two gases. So in this case, we're going to be having since we're having two gases now, R1 over R2 will be equal to the density of D2 and D1. This is for the first gas, the rate of diffusion for the first gas, the rate of diffusion for the second gas, and so on and so forth. You should always remember that this is in a cross multiplicational form, RD. So R1 to its D1, R2 to its D2. That's the case, the chemistry here. So we also remember that relative molecular mass is equal to 2 times the vapor density. All right. So if that is true, I can equally say this is equals to the M2, the relative molecular mass, over M1. This is how we go. We're going to make use of this elaborately. And it is pertinent that we don't forget another formula. The rate, let's call it R1 of gas 1, will be equals to V1. Okay, let's just call it rate is equal to V over T. Okay, so if we are dealing with two gases, therefore we say R1 will be V1 over T1 and R2 will be V2 over T2. So this can be substituted in a place where we see our R, okay, if peradventure the question encompasses that. So let us take maybe one question first of all to see what if 280 cm cube of hydrogen diffuses in 40 seconds. How long will it take for 490 cm cube of a gas X? So we're having two gases here, hydrogen gas and gas X, which is the unknown gas, whose vapor density is 25. They're giving us the vapor density to diffuse under the same conditions. So let us begin by bringing out the given. This is given to us. So we have hydrogen. This is hydrogen gas in its form. And the other gas is X, unknown. So I'll call this V1 because hydrogen is the first gas. The volume is given to be 280 for hydrogen, so that's V1. So here it will be what? V2. Okay, if 280 cm cube of hydrogen diffuses in 40 seconds, so there is also time. T1 is 40 seconds. Okay, how long? They are asking us. Okay, this is 490 cm cube. How long? T2 is what we don't know. They're asking us of the time. How long will it take 490 cm cube of a gas X, okay, whose vapor density is 25, to diffuse under the same conditions? Now the vapor density, let's call it the density of this gas, is 25 of gas X. Now, we know too well that relative molecular mass of a gas is 2 times its vapor density. Okay, so let's say the M2, this will be M2, but in the question they give us relative molecular mass of hydrogen to be 2. So this is M1 is 2. So now here, the relative molecular mass will be 2 times 25, which is 50. Call it Gmol or something. I don't know if I am communicating. Now, this is what we can get from the question before we can start solving. Remember, we have various formulas. So now let's see how we're going to resolve this. So I say I have my R1 for the first gas, R2 for the unknown, is equals to, I'm going to use this other formula, M2 over M1. Because I've been able to, they give me the relative molecular mass of this, and I'm able to get this other one because I remember the formula that says relative molecular mass is 2 times its vapor density. Therefore, 2 times the 25 which has been given to me will give me 50. So I move on. So if this is the case, I'm trying to see if I can shift this things a little bit so that I can make good use of that side. Okay. If this is the case, let me put those variables here. V2 is 490 cm cube. T2 is what I'm looking for. N2 is 50. I think that is fine. That is for X. Okay, from here, because volume is given and time is also given, so I have to use this. R1 is the same thing as V1 over T1 divided by R2, which is V2 over T2, which is equals to M2 over M1. Now, if I cross over here, okay, let me take this out. V1 over T1 times fraction says in the laws of fraction that when you change this to a multiplication sign, the position of these variables will change. This will go up and this will come down. So Botman's. So now I have T2 over V2. All of this is equals to M2 over M1. Okay, now I want to substitute the variables inside. V1 is 280, T1 is 40 seconds times T2, which we're looking for. Okay, yeah. Then V2 is 490. This is equals to the root of M2 is 50, M1 is 2. So 280 times this, I have 280 T2 over 40 times 490. 490 is 19,600. 19,600. This is equals to the root of 25. 50 divided by 2 give me 25. So let's see. Okay, let me take out this 1 out. I have 28t over 1960 is equals to 5. The square root of 25 is 5. So I'm going to cross multiply. Alright, 28t times 1 is 28t. This is 1960 times 5. 1960 times 5 is 9,800. 9,800. Now divide both sides by 28. 28. 28. This will go at my T2. Where do I start writing my 2? My T2 will be 9,800 divided by 28, and that will give me 350. 350 seconds. So from the question they say how long will it take? So it takes 350 seconds to achieve that. Okay, it is important if we don't forget that rate is also V over T, the volume time over time. If we don't remember that, we'll find it difficult to be able to bring out the combinations and all that. But let's solve more questions so that in case we do not understand very, very well, the whole picture will become clearer as we proceed further. Now, question number 2. Please, let me take this up. Under the same conditions of temperature and pressure, remember that is what the law says, Graham's law of diffusion, that the temperature and pressure remain constant before it can be obeyed. Hydrogen diffuses 8 times, okay? There are 2 gases, this is hydrogen. Diffuses 8 times, okay. What is it? 8 times as fast as a gas. Why? So we have 2 gases, hydrogen and gas. Why? Now, the rate at which hydrogen diffuses is 8 times. So let's call this our R1 is 8. Our R2, okay, is 1 because it's 8 times that. Okay? Now let's move on. Calculate the relative molecular mass of Y. Relative molecular mass of hydrogen is 2. They've given it to us. So M1 is 2. M2 is what they're asking us to get. It's unknown. So I think this is more straightforward, I think. Now we have the formula says R1 over R2 is equals to relative molecular mass of M2 over that of M1. R2 is 8. Sorry. R1 is 8. Okay, I'm correct. It's 8. R2 is 1. And this is equals to the root of M2 is unknown. Let's call it X over the M1. M1 here is 2. By cross multiplication, I have my root X is equals to 8 root 2. Now, in indices, we've been told that when we remove the root of x, in order for us to remove the root of x, we have to square both sides. Okay, square both sides by, okay, just square both sides. And when we do that, this will be gone. So how do we do that? So this is the root of x squared is equals to 8 root 2 squared. If I cross over to this other side, the square of this is x, give us x. And this becomes 8 squared times 2. X is 64 times 2, and my x is 30. Okay? Times 2, 128. 128. That is the relative molecular mass of the unknown 1. It's 128. Okay, that aside, let me explain this, okay? Why do we square this and this is... Square root is the same thing as 1 over 2 in indices. So if this is x, here become, if this is x is inside, here become x raised to power 1 over 2. That's what it means. So if these two things are the same, and we say we should square both sides, which is this square, like I squared here, okay? When I squared here, I got x alone. So if this root sign is the same thing as 1 over 2, therefore, how do we get rid of this? So Power's law of indices says that when a number x is raised to a certain power, which is again raised to another power, this number x is said to be in powers, that the powers are multiplied together for final evaluation. So therefore I have, this is my x raised to power 1 over 2 times 2. 1 times 2 is 2. So this is 1 times 2 is 2 divided by 2. 2 divided by 2 here gives us 1. So that x raised to power 1 is x. That is how we have, when we did this, we now have x. So this is an explanation from Boyce, how they call it, indices. Let's take another question, please. Question 3. 80 cm cube of chlorine gas. So I have my first one here, chlorine. Chlorine gas is often Cl2. Yeah. Let's say 80 cm. So this is my first gas. So its V1 is 80 cm cube. That uses through a porous pot in 60 seconds. T1. 60 seconds. For the same volume of an unknown gas to diffuse through the same pot, the unknown gas, let's call it X. For the same volume, so V2 is also 80 cm cube. Okay, we should calculate the relative molecular mass of the unknown gas. 90, okay, sorry, it seems I skipped something. You say 80 cm of chlorine gas that fuses through a porous pot in 60 seconds. Okay, I have that. While it takes 90 seconds, sorry, T2 is 90 seconds. While it takes 90 seconds for the same volume of an unknown gas to diffuse through the same pot, calculate the relative molecular mass of unknown gas. M2 is what we're looking for. Yeah, M2. We know the relative molecular mass of chlorine itself is 35.5. This is M1. 35.5. But chlorine gas contains 2 in it. So times 2, which is equals to 71. So we are to get our M2 if M1 is 71. Alright, let's start. We have R1 over R2 is equals to the root of M2 over the root of M1. R1 is the same thing as V1 over T1 divided by R2 is V2 over T2, which is equals to the root of M2 over M1. V1 over T1 times T2 over V2 is equals to the root of M2 over M1. Okay, let's cross over here. V1 is 80. T1 is 60 times T2 is 90 over V2, which is also 80. This is equals to M2 is unknown, and M1 is 71. This will go with this, so we have 90 over 60 is equals to the root of M2 over the root of 71. I want to make this a subject, so I have 60 root M2 is equals to 90 root 71. I divide both sides by 60, so this will go, I have root M2, is equals to 90 over 60 root 71. Let's come over here. Now, 90 over 60 is 19 divided by 60 is 1.5. So I have root M2 is equals to 1.5 root 71. I'll take out these roots, so I square both sides. So here become M2 is equals to 1.5 square is 2.25 times 71. Because 71, the root of 71 is 71. Okay, we've illustrated that earlier on. So I have my M2 is equals to 2.25 times 71 times 71 is 159.75. 159.75. M2 becomes 159.160. Relative molecular mass is GMO, but let's say that's what we have. So again, there we go. We must have a formal knowledge of indices. In short, for us to be able to excel properly in this topic, we must have our formal knowledge of mathematics. Because when we deal with fractions in here, and we also deal with indices elaborately. So if you do not understand indices and equally change your subject or formula, that's about 3 topics in mathematics. With time, probably I'm going to have lectures on them, but for the time being, this is what it is. So for you to be able to go through this topic very well, I would advise you can go back to do some revision on those topics. It will really help you to understand exactly what we're dealing with. So that's our 3rd question. Let's take the 4th question. All right, the 4th question here says, it takes 4 seconds for hydrogen to diffuse from one end of a gas jar to another. It takes 4 seconds. So let's take with hydrogen. So this is my gas hydrogen. T1 is 4 seconds. Okay, from one end to another. How long will it take oxygen? This is oxygen. So T2. Now the question says, How long will it take oxygen to diffuse through the same distance? Now, how long will it take? That's the T2. Now, let's look at the relative molecular mass of hydrogen. M1, is 2, because this is hydrogen gas. The relative molecular mass of this is 2. And that of oxygen, this is oxygen gas, which is 16 times 2. M2 would be 32. Yeah. So, they did not give us the, how do I call it, the volume or thereabout, but we know that this reaction takes place under the same condition of temperature and pressure, so which means the volume here doesn't change. So in order for us to go through it, this is what we do. We have our normal rate, R1 over R2 is equals to the root of M2 over the root of M1. So R1 is V1 over T1 divided by V2 over T2. This is equals to the root of M2 over the root of M1. So if I change this, V1 over T1 times T2 over V2 is equals to the root of M2 over the root of M1. So this will go with this, obviously, and I will be having T2 over T1 is equals to the root of M2 over the root of M1. Now, what we'll be looking for? We're looking for T2. Now, let's substitute the variables inside. So I have my T2 over, which I'm looking for, T1, where are you? T1 is 4. This is equals to the root of M2. M2 is 32 over the root of M1, which is 2. So this is the same thing as T2 over 4 is equals to the root of 32 over 2. The topic is solved in mathematics. Root 32 divided by root 2 is the same thing as the root of 32 over 2. That is math. So let's proceed. Now, this is T2 over 4 is equals to 32 divided by 2 is the root of 16. And let me cross again. T2 over 4 is equals to the root of 16 is 4. So this is 4 over 1. By cross multiplication, T2 times 1 is T2, and 4 times 4 is 16. So it takes, when it takes 4 seconds, for hydrogen to diffuse, it takes 16 seconds for oxygen. So that is that. If 100 cm cube of methane, so the first gas here is methane, CH4, is the relative molecular mass, the molecular formula. So our V1 is 100 cm cube. If it takes 100 cm cube of methane to diffuse through a porous spot in 1.0 seconds, so T1 is 1.0 seconds. Now, how long will it take the same volume of sulfur? So, of what? Of sulfur 4 oxide, which is SO2, the same volume. So V2 is also 100 cm cube. How long is T2? That's what they're asking us. Will it take that sulfur 4 oxide to diffuse through the same port under the same conditions? They've given us the relative molecular mass of hydrogen, oxygen, carbon to be 12, oxygen 16, and sulfur is 32. So let us begin. Now, my M1, the relative molecular mass of this, carbon is 12, plus oxygen is 4, hydrogen is 4, 12 plus 4 is 16. Now, my M2, sulfur is 32, plus oxygen is 16 times 2, 32, 32 plus 32 is 64. So, let us proceed. So if that is true, following our formula rate of diffusion, R1 over R2 is equals to the root of M2 over the root of M1. R1, which is the same thing as V1 over T1, divided by V2 over T2 is equals to the root of M2 over M1. So my V1 over T1 times T2 over V2, is equals to the root of M2 over M1. Let's move over. Volume being equal, 100, 100, I can equally strike them out because it will still go. So I have T2 over T1. So T2 over T1 is equals to M2 here is 64 over M1 is 16. So, and T1 is 1. So let me just put it here, 1.0. So I have T2 over 1 is equals to, let's look at this, 64 divided by 16. Is it necessary? 64 divided by 16 is 4. Okay, so this is 4, so I have the root of 4 here. Now, cross multiplication, this is over 1, T2 is equal to 1 times root 4, which is root 4. So my T2 is equals to 2 seconds. Because the root of 4 is 2. We have been asked to calculate the relative molecular mass of a gas. So the gas, we don't know. If a given volume takes 60 seconds to diffuse through a porous plug, whereas an equal volume of oxygen takes 80 seconds. So there is a first gas which is unknown, let's call it X, and there is another called oxygen. So they say we should calculate the relative molecular mass, M1 of that gas, we don't know, so M2, oxygen is 16 times 2, which is 32. So we know that of oxygen. Okay, 60 seconds. So calculate the relative molecular mass of a gas if a given volume takes 60 seconds. That volume, V1, and the time for T1 is 60 seconds. V2 and the time for T2, we don't know yet. That is through a porous plug, whereas an equal volume of oxygen takes 80 seconds. Is it 80? Yes. This is 80 seconds. The volume too, we don't know. But the volumes are equal. If the volumes are equal, means they are going to cancel out. So they say we should find this. So starting with the formula, R1 over R2 is equals to the root of N2 over the root of N1. R1 is V1 T1 divided by V2 T2 is equals to the root of N2 over N1. And there I have V1 over T1 times T2 over V2 is equals to the root of M2 over M1. Now they say they are equal volumes. So I have T2 over T1, T2 over T1 is equals to the root of M2, the relative molecular mass of the oxygen here is 32. Why? That of M1, we don't know. So I have my M1. Okay, this is the same thing as T2. Let's put the time now. Now, the T2 is 80 seconds. 80 seconds. T1 is 60 seconds. This is equals to M2 over M1, making M1 is the root, of M1. So now to cross multiply, I have 80 root M1 is equals to 60. M2 is 32. 60 root 32. Divide both sides by 80. by 80. So this will go, I have my root of m1 is equals to 60 over 80, 60 divided by 80, 0.75 is equal to 0.75 root 32. To remove this root, I square both sides. So I have my m1 is equals to 0.75 squared, give me 0.5625 times 32, because the root of 32, the square of the root of 32 is 32. Come over here again. So my m1 finally becomes this times 32 times 32. I have 18 G mole or whatever it is. So that is the relative molecular mass of the unknown gas X. That of oxygen we could determine that. Okay, let's take another question. Am I clear? 60 cm cube of a gas A. So this is a gas A, 60 cm cube. So V1 is 60 cm cube of a gas A that freezes out in 8 seconds. T1 is 8 seconds. And 120 cm of another gas B, this is B, V1 is 120 cm cube of another gas B, okay, that freezes in 12 seconds, T2, 12 seconds. Calculate the rate of diffusion of the two gases. This is interesting. The rate of diffusion of the two gases. Remember, I told us earlier on in the formula section that rate is equal to volume over time. So I think this is where it comes. So gas A rate is equal to V A over T A, as the case may be, if I want to call it one or thereabout. So this is equals to, the volume is 60 cm cube. The time is 8 seconds. So this definitely is 60 over 8. Over 8, I have 7.5. So 7.5 cm cube per second. Gas B rate is equals to volume of B over the time of B, and this is equals to the volume is 120 cm cube over the time is 12 seconds, and this is equals to 120 divided by 12 is 10. So I have 10 cm cube per second. So that's that. How many times is the rate of diffusion of hydrogen? So I have hydrogen faster than that of oxygen. I have oxygen. And what law do you use to get the answer? The vapor densities of hydrogen. Vapor density of hydrogen is 1, and that of oxygen, density for oxygen is 16. We say, how many times is the rate of diffusion? First off, okay, let's start. This is rate for hydrogen, which is my arrow. This is my arrow to rate for oxygen. is equals to the root of M2, which is of oxygen, M1 for hydrogen. Don't mind me, I have to put it that way. Okay, rate of hydrogen. Okay, let's go back to this, guys. So let's maintain this rate of hydrogen over rate of oxygen is equals to the relative molecular mass of oxygen. Density is 2. Relative molecular mass is 2 times vapor density. 2 times 16 is 32. Over hydrogen is 2, I think, just 2. So if I come down here, the rate for hydrogen over the rate of oxygen is equals to 32, okay, over 2. Good. So let's go with the rate for hydrogen over the rate of oxygen is equals to, this one goes here 1 time, it goes here 16 times. So this becomes the root of 16 over the root of 1. Now, the rate of hydrogen over the rate of oxygen. So this is equal to 16. The root of 16 is 4, and this one is 1. So, that is it. So the rate is, here we have 4:1. Let us proceed. So the rate at which oxygen diffuses is 4 times, remember this is how they call it, M2, is 4 times the rate at which hydrogen diffuses. What again did I say? And what law do you use to get the answer? The law is Graham's law of diffusion. So it's kind of straightforward. Let's proceed. In 30 seconds, 180 cm3 of oxygen. So the first gas here is oxygen. In 30 seconds, T1 is 30 seconds. 180, okay, V1 is 180 cm3 of oxygen diffused through a porous plate. How long will it take 300 cm3? V1 here is 300 cm3. How long? Sorry, this is V2. T2 is the time they are asking of us. How long? We take chlorine. Second gas is chlorine. So oxygen, if I have to. Chlorine to diffuse through the same plate. Vapor density of oxygen is 16. Vapor density of oxygen is 16. And that of chlorine is 36. So remember, relative molecular mass is equals to 2 times its vapor density. So I don't need to deal with the D directly, although I can still use the formula because I still have R1 over R2 is equals to D2 over the root of D2 over the root of D1. So I can apply that directly, but we can still use the relative molecular mass. So R1 over R2 is equals to the root of M2 over the root of M1. R1 here is the same thing as V1 over T1 divided by, which is this, V2 over T2 is equals to the root of M2 over the root of M1. If I cross over here, okay, now, both mass, this have to change. I have V1 over T1 times T2 over V2. This is equals to the root of M2 over the root of M1. Now, what's V1? V1 is 180 cm3 over T1 is 30 times T2 is what we are looking for, we don't know, over V2, V2 is 300. This is equal to the root of M2. M2, this is my 2, 36 times 2. Okay, 36 times 2 is 72. 72 over the root of m1. 16 times 2 is 32. I guess I'm right. Yes, 16 times 2 is that. Okay, so I have 180 T2 all over 30 times 300. 30 times 300, which is 9,000. 9,000. This is equals to the root of 72 divided by 32 is 2.5. So 2.25. So I'm not going to break it down. I have to leave it the way it is to get our destination. So now I have the root of 72 over the root of 32. Now I have to cross multiply. This is what I'm looking for. And I try to summarize it all inside to enter. So I have 180 T2. 180 T2 times root 32 is equals to 9,000 root 72. I am dividing both sides by 180 root 32. Alright? So I go 180 root 32, 180 root 32. So this will go, I'm left with my T2, which is equals to this. Now 900 divided by 180, can it? 180 is 5. So now this is 5 root 72 over root 32. Okay, so now we're going into a different dimension. We're entering sort. This is mathematics. I never thought they're going to take us here. So in sort, we say we never leave a root sign down. So what do? We rationalize. So I have my T2 is equal to 5 root 72 times root 32 over root 32. So times root 32, because you use the root and multiply both up and down. That is the law. So T2 will be 5 root 72 times root 32 over root 32 times root 32 is 32. So T2 will be, now this is 5 times root 72 times 32. 72 times 32 will be 2304. 52304 over 32. Let me see if I can rush that up. I don't want to occupy more space. So this is 2 is equals to, I have to look for the root of that, multiply by 5 and divide by 32. Whatever we have becomes our answer. So the root, where is it? The root of 2304 is equals to 48, funny enough, times 5 is 240, divided by 32 is 7.5. So T2 is 7.5 seconds. To be frank, I never anticipated that we are going to get into sort. So in the course of your going through rate of diffusion, it is pertinent you should have revision on sort fully, like we have seen now. Change of subject or formula, indices, fraction. These topics in mathematics are pertinent for you to be able to solve certain questions in chemistry. Chemistry encompasses a whole lot. You know, maths, chemistry, physics, they are very, very alike. So I believe with time I'm going to make lectures on these essential topics in mathematics so that we're not going to be found wanting. I think we're just left with one more question, then the other one will be taken as assignment. So let's quickly run through and see what we have. Our last question for the day. So let me take. Okay, a gas diffuses out through a porous pod at a rate of 47.15 cm³ per second. The gas is unknown. So we don't know what the gas, but the rate at which it diffuses is 47.15 cm³ per second. Under the same conditions, oxygen, so let's call this one, the gas is unknown. This is oxygen. Under the same condition, this is R1, this is my R2. Oxygen diffuses, under the same conditions, oxygen diffuses at the rate of 16.40 cm³ per second. Calculate the relative molecular mass of the gas. Okay, I think I know where they're coming from. Oxygen is always 32, M2 is 32, and M1 we don't know. So we have R1 over R2 is equals to the root of M2 over the root of M1. R1 is 47.15, R2 is 60.40, is equals to M2. M2 is 32, the root of 32 over the root of M1. That's what we're looking for. Cross multiplication, I will have 47.15 root M1 is equals to 60.40 root 32. Divide both sides by 47.15. This will go with this. So root M1 is equals to this. Okay, let's take that. 60.40 divided by 47.15. 1.28. Let's just call it like that. 1.28 root 32. To remove this, I square both sides. So when I square both sides, I now have my M1 is equals to 1.28 squared. When I square this, I have 1.64. 1.64 times 32. The square of root 32 is 32. So when I multiply this with 32 times 32, I have 52.5. So M1 is equals to 52.5. Relative molecular mass is G mole. So we are going to, calculational wise, we'll stop here, but I give you one as assignment, so you're going to take care of that. The question says, the relative rate of diffusion of a gas as compared with oxygen. So the gas is unknown, which is, you should always have that in mind. The rate, R, which we're looking for, the relative rate of diffusion of a gas as compared with oxygen is 2:1. So the gas is 2, oxygen is 1. Calculate the relative molecular mass of the gas. So if you know your relative molecular mass of the oxygen as compared to the other one, you'll be able to go through. So like I said earlier on, we're going to stop here. But don't forget, we have been able to cover the Boyle's law, the Charles law, the general gas law equation, and this is Graham's law of diffusion. We also have the other ones like Avogadro constant, and so on and so forth. But we're dealing with the essential ones, which you should know and know how they work. So like this is very cardinal in the course of our discussion today. But I guess truly or strongly that we're still going to have more time so that we'll be able to deal with things which are very essential to us. So for the time being, you have a wonderful day or a wonderful night based on the time you're watching it, and see you another time. Thank you.